Kemija. Što je kemija? Kemija je znanost koja proučava sastav, strukturu i promjene tvari. Tvar je sve što zauzima volumen i ima masu. Kemijske znanosti temelje svoje teorije na osnovnom principu prema kojem su svi materijali koji nas okružuju sastavljeni od atoma, vrlo malih čestica nevidljivih golim okom s neutralnim električnim nabojem i ajona, čestica koje imaju pozitivan ili negativan električni naboj. Molekule i periodni sustav elemenata. Velika raznolikost oblika i boja kojom se tvar pojavljuje u našim očima posljedica su načina na koji se te čestice mogu međusobno povezivati kako bi tvorile puno složenije strukture, koje nazivamo molekulama. Atome je organizirao i klasificirao u periodni sustav ruski kemičar D. I. Mendeljev, 1834. 1907. Periodni sustav koji je predložio Mendeljev ne odgovara današnjoj tablici, ali klasifikacija elemenata koji je predložio i dalje je u osnovnim crtama važeća. Trenutno su elementi poredani prema rastućem atomskom broju Z, a ne više prema atomskoj masi.
Hey friends, if chemistry isn't really your thing but you're curious and love discoveries, you're in the right place. Today we're going to amaze you. Let's talk about atoms, those tiny building blocks that make up everything around us. Imagine them like those famous Lego registered trademark bricks that you can use to build anything. Atoms join together, creating chemical bonds, and they form different molecules and compounds. And do you know what chemical equilibriums are? They're like perfect scales that keep everything in harmony. Chemistry is truly everywhere. It's the science that reveals the secrets of matter. Are you ready to explore this fascinating world with us? Subscribe to the channel and dive into the wonders of chemistry. Stop struggling with chemistry. Learn these fundamental properties of the periodic table in a minute. Ionization energy is the energy needed to remove an electron from an atom. The higher it is, the harder it is to make it say goodbye. An electron affinity? It indicates how much an atom wants to gain an electron. The higher it is, the happier the atom will be. Then we have the atomic radius. Think of it as the size of an atom. It gets smaller as you go from left to right on the periodic table. Finally, electronegativity. It's the strength with which an atom attracts electrons to itself in a chemical bond. The higher it is, the stronger the attraction. Keep these concepts in mind and chemistry will seem like a piece of cake. See you next time, aspiring scientists. Hey everyone! Today we're diving into the amazing world of chemistry. We'll explore mixtures, molarity, atoms, chemical bonds, reactions, and chemical equilibriums together. Are you ready? Let's get started. Let's begin with mixtures. There are two main types, homogeneous and heterogeneous. Think about salt water. The salt dissolves completely, creating a uniform solution. which is a homogeneous mixture. However, a heterogeneous mixture, like sand in water, is not uniform. The sand settles at the bottom, making the mixture not uniform. Now let's talk about concentration, specifically molarity. Molarity tells us how much of a substance is dissolved in a solution. It's measured in moles of the substance per liter of solution. Imagine dissolving 1 mole of salt in 1 liter of water. You'll get a solution with a molarity of 1 m. Now let's get to the heart of matter, atoms. Atoms are the basic building blocks of everything around us. Every atom is made up of protons, neutrons, and electrons. Protons and neutrons form the nucleus, while electrons orbit around it like tiny satellites. When two atoms come close together, they can join and form chemical bonds. There are two main types, covalent and ionic. A covalent bond is formed when two atoms share electrons. Think about the oxygen and hydrogen molecules in water. They're held together by covalent bonds. In an ionic bond, one atom gives one or more electrons to another atom. A classic example is sodium chloride, our table salt. Alright, now let's dive into chemical reactions. A chemical reaction happens when reactants transform into products. For example, when you burn a piece of wood, the carbon in the wood reacts with oxygen in the air, forming carbon dioxide and ash. Finally, let's talk about chemical equilibriums. In some chemical reactions called reversible reactions, the reactants turn into products and vice versa. Chemical equilibrium is reached when the rate of the forward reaction becomes equal to the rate of the reverse reaction. An example, the reaction between acetic acid and sodium acetate in solution. So here we are at the end of our chemistry journey. I hope this review was helpful for you. Remember, chemistry is everywhere, from our bodies to the food we eat, to the stars in the sky. Keep exploring and discovering, because chemistry always has something new to teach us. See you next time.